I'm performing a home inspection on a house that was built approximately about 14 years ago. This is a single level house with a basement, a finished basement. We're on the water, very beautiful lot. This house actually has poured concrete foundation walls. It was built really well. Take you around the basement. You can see behind me, obviously this is a daylight wall. We've got a covered deck there, so these are daylight walls. And then as we go towards the front of the basement, these walls are going to have ground level is about midway to, I don't know, 6 feet up that wall. And then at the front, it's probably 7 to 8 feet to the ground level. So the front walls, side walls are submerged below the soil, back walls are open. Now, what we're going to look at is, I've already checked all of the foundation, the perimeter walls that are below grade. I've already checked those for moisture entry, water entry. And I didn't find any indication of water entry whatsoever. Typically with poured concrete walls in our environment or our area, they typically perform well. And that's not the exception here. That's actually what's going on, is I don't have any indication of moisture intrusion from groundwater. But what I do have is indications of moisture where we have cracks and openings in the concrete slab. So this is against the kind of the middle of the house, kind of towards the back, but this area is towards the middle. You can see the cracks in the concrete slab. Notice when we get to this wall, notice the efflorescence that's on the concrete. You can see the staining on the baseboard. What's happening is moisture is below this slab. Now, I don't think that we've ever had water that accumulated and flowed across the concrete, but what we're seeing is vapors that are coming up between the cracks, and when it comes up through the cracks in the room, basically the vapors will come up and get caught up into the air and get circulated through the HVAC system. The HVAC will handle that moisture, will actually pull that out of the air and take it out of the house. But where we have cracks that extend below walls, on the other side of this, there's another room and this crack goes all the way through. Where this crack is going through and there's a wall above it, that vapor will hit our building materials, and you can see the staining on the baseboard, the swelling. That moisture will collect on our building materials. So the vapors that are underneath this concrete are coming up into the house, and if we've got a wall on top of it, then it's going to catch that moisture and it's going to damage our building materials. Again, daylight wall, we're not below grade in this area, but we still have efflorescence around the edge of the slab. Same thing here. Discoloration on the baseboard, efflorescence on the slab, discoloration there. I'm going to take you to one more spot. Again, this is the front wall. I've checked all of these walls with the meter and everything is dry up high. Down low, it does start to read a little bit higher, but notice all of the efflorescence around that. It's actually started to chip up a lot of that concrete because of all of that moisture, basically moisture that accumulates right below the surface of it, and you can see the concrete's flaking off. Now, if we come over on this side, again, interior wall on the other side of this. Notice the heavy efflorescence on the floor. But if you come up and look, take a look there. Starting to see some mold come up. Now again, I don't expect, or I don't anticipate this to be moisture intrusion. But the problem is these vapors that are coming up between the cracks, if they touch our building materials, if drywall gets wet, it can grow mold. If baseboards get wet, they can grow mold, but they can also be damaged too. So how do we correct it? Now, my clients that I'm working for, they were here a few minutes ago, and I was showing him some of these things, and he said, well, can't we just put Kills over it and paint over it and call it a day? Yeah, you can. You can, but it's not going to fix the problem. And so my solution to the problem is, what's going on is we've got the vapors that are coming up between the concrete. Basically, we're going to have stack effect in the house. We're going to have this natural draw of air from the bottom to the top. We need to reverse that. We need to have a negative pressure below the slab so that any vapors that are down there would either be dried out or would be drawn under the slab and out through a different way, instead of coming into the house. Well, the solution to that is to do a slab depressurization system or a radon system. That's the same thing. If you put a radon system into this slab, then it's going to create negative pressure under the slab. Basically, we're going to have a pipe that extends into the concrete. That pipe will go outside, it'll have a fan attached to it, and then another pipe extending above the roof. And that fan will operate and it will create negative pressure below the slab. Those vapors, as well as the radon, will be drawn through that pipe and distributed outside, thus not allowing it to come into the house. So if we did that, if we took this, for example, this area, if we sealed this crack from the surface using epoxy and seal that as good as we can, and then we install a radon system, now any vapors that are there are going to be pulled down. We're actually creating a little bit of negative pressure in the house, but that's what we would rather see, because that's the only way that we can control these vapors. Even if we seal these cracks up that are on the floor, you still have the edge of the concrete along the whole perimeter that's showing the signs of allowing those vapors to escape there. So the only way that we can truly get that vapor to stay down would be to create suction underneath it, and that you do that with a radon system. So I thought this was pretty interesting. It's a good visual for how the vapors can come up through concrete slabs and affect the inside building materials. But again, the answer for that slab depressurization system, aka radon system, you can take those vapors, have them drawn out, creating that negative pressure, and that way they don't come up and touch our building materials.